we're going to start the unit on matter, and the first thing we're going to start off with phases of matter. I prefer calling them states of matter. In the chemistry textbook, you will learn phases actually represents the different layers or parts of a mixture, and then states are what we commonly then use for the term for solid, liquid, and gas. So there are three common phases or states of matter. Your textbook uses the term phases, and then later they switch it to the term states through the same publisher for the chemistry textbook. So solid, liquid, and gas. Solids. Solids have a definite shape and volume. They're not easy to deform. Another way of thinking about this is it does not take on the shape of a container and it does not fill the container. So if you have a cube, it'll be a cube no matter where you put it. The molecules or atoms are in fixed positions. They vibrate or they have rotational movement. They are extremely fast. They do not move or glide past each other. They sit in one area. So if you think about the classroom situation, you are sitting at desks. You have definite positions. However, you can move within your seat by writing and you're fidgeting or whatever you need to do. So I think of you guys in the classroom as solid matter. Liquids have definite volume, but they have indefinite shape. So when you have a liquid, if you have 1 gallon of milk and you so happen to drop the container, you still have a gallon of milk. It's just all over the floor now and spilled. So the gallon is still present. However, the shape is no longer the shape of the container. It is just a big puddle on the floor. So liquids have definite volume, but indefinite shape. So they take on the shape of a container. However, they do not take up its space. The molecules within the liquids do move around. They slip past one another, and we call this that they are condensed, but they are free-floating or fluid. So liquids are also known as fluids. Gases. Gases do not have definite shape or definite volume. So it's indefinite shape, indefinite volume. They will take on the shape of a container as well as the space of the container. So when you're sitting in the classroom and you just move the shape of the air around you. It is conforming to what you are doing. They are very fast moving. They move freely, so they're also known as fluids, and they're not tightly packed, so they are not considered condensed pieces of matter. At the atomic level, solids, the atoms attract each other and hold each other in fixed positions. Motion is due to heat, and we do have them vibrating or rotating in place. So at room temperature, we have a lot of items that are solid, and then if we change the temperature, we can turn them into liquids. Doesn't work for everything, but solids are very tightly bound, condensed, and they are in their fixed positions. Liquids, the atoms or molecules are still touching, but they do have energy, and so the amount of heat needed to make them move is less. So we have liquids at room temperature, and if we would like to get them moving even faster, we do heat them up, and they are not condensed, they're not tightly packed, they are free moving, so they do have more energy. The gases, the atoms are not touching or molecules are not touching. They are completely moving all over the place, whipping around the room. And if you think about it, if somebody sprays a perfume or uses hand sanitizer, it evaporates and then we can smell it within seconds or minutes of them using it because those molecules are moving around. When they do crash into each other, the it decreases the distance that they move. So there are collisions, and it's keeping them from flying further away. So those collisions cause them to move in a different direction, or change completely their direction, or not be able to move as far in that direction they were originally going. There is another state called plasma. There's also one called Beck's, but we are not going to talk about those. They are mentioned in your textbook. Beck's is the Bose-Einstein condensate. That's like a super solid, so we won't talk about those. But plasma is a really hot gas. It is made up of particles that have an electric charge. So those particles shake violently at high temperatures, and the molecules are broken down into nuclei, and electrons are moving extremely fast, producing an electromagnetic field. Prime examples of plasma are the sun and the stars. Now we also now have plasma TVs. It's not saying your screen is plasma. There is a small little teeny tiny area in your TV that is running from plasma. So it's not saying that that entire screen is made up of plasma, and that's something you can learn in physics class or in the physical chemistry area. So let's look at the characteristics of the three major phases of matter. So we're looking at the phases or states, solid, liquid, gas, whether or not they have definite mass, volume, shape, or if they're easy to compress. Solids do have definite mass. They also have definite volume. And you can put X's in there or say yes or no, whichever makes life easier for you. They do have a definite shape, and they are not very easy to compress. You cannot squeeze a brass rod and just squeeze it and change its shape. Now there is some matter you can squeeze and reshape, but you're not compressing it. You're not making it smaller. Then we have the good old liquid. Liquids are definite mass, definite volume, so when you have a sample of that matter, you're not changing those two items when you move them around, but you can change the shape. They are very easy to compress, not easy to compress. You can compress them a little bit, but you're not squeezing them a lot. So if you fill a tire to maximum capacity with water, you won't be able to squish it too much, but you might get a little bit in there. Gases do have definite mass, so if you do have a sample of a gas, the mass will stay the same. However, the volume will not stay the same, so as soon as you move it to a different container or take the lid off, the volume will change, so that mass will move around. The shape is also indefinite, so you will take on the shape of the container or the room or the motion of what other items that are within or mixed in with that gas. They are easy to compress. So if you put air in a tire and you fill it to capacity, you can still usually squish it down, and even if you don't think about it, whenever you get into your car, your tires do squish down a little bit. So it may not be easy to do just by your hand, but when you put enough mass on it, you can compress a tire. So there are the different states of matter, and if we're talking about a certain amount of sample, what happens to the volume, the shape, or is it something you can compress for those different states of matter? Properties of matter. A property is what we use to identify a trait or characteristic. So it's our descriptor of what that matter is. There are different types of properties. There are physical and chemical properties. So we're going to start off looking at physical properties. Physical properties are any physical characteristics of the substance, meaning when we observe them or we make changes, we're not changing what it is. So they're characteristics that can be observed or measured without changing the actual composition. Some of these items consist of color. The fact that something is red is a physical property. Its density, so elements of the periodic table have accepted densities. Their hardness, whether or not you can scratch or make dents in them whenever you apply different types of tests to them. Their shape or texture, the melting point, freezing point, Boiling point is also one that I would add to that list because melting point and freezing point are technically the same thing. One thing to think about, if you have a piece of paper and you rip it in half and you keep ripping it, it's still paper. You're not changing what it is, you're just changing the shape of it. Physical changes are when you're actually doing these items to the object. So the ability to change its shape or change its state is the property, and then when you actually do change its shape or state, you are making the change itself. So it is still not changing the identity of the substance. So the definition, a change in which a substance changes its physical properties without changing its actual identity or chemical identity. So once again, we can talk about tearing a piece of paper, writing on a piece of paper, playing with Play-Doh. So ice melts to water. It's still water. You still have H2 in the solid phase, and then it goes to the liquid phase. So H2O is H2O no matter what. We still have the same atoms here. It's just that they're moving around or we're changing their formation. So there are 4 different atoms here, possibly moving around or going in different directions, and you still have those atoms when you make those changes. So it's not changing them at the molecular level. Chemical properties are when you actually change its identity. You create new matter. So it's a tendency of a substance to change its chemical identity. So if you have iron and you put water on it, and it has oxygen also when it's present, it will rust. So that beautiful piece of iron starts to look like that ugly orangish crusty stuff. So the willingness to mix with other elements, which could change their chemical identity. Baking is often doing chemical changes because you're breaking cells up and you're changing its color, like toasting a marshmallow. If you just heat it so it melts and it dries out, that would be physical. However, if you put it in the fire and it turns brown or catches on fire, you're doing chemical change. So you're actually creating different matter from those items. When we talk about chemical changes, we also refer to them as chemical reactions. So it's the change in which a substance changes its identity, atoms are rearranged to give new substances. So wood burning, you can't unburn a piece of wood. When you burn the wood, you form carbon dioxide and water vapor. And if it doesn't burn, do complete combustion, you may have some ash or some other items left over. Grape juice does fermentation, so you create alcohol or wine from that. The colors may still be the same, so there may be some properties that don't change when you see that, but you are making a new substance. Chemical changes at the molecular level. If you're looking at atoms, and here we have the green and blue atoms, and they are in motion, and we add another substance to it, or we're going to make the change. They'll move around, and we have different things combining. So now we have the yellow mixing with the green, and the blue ones now are running away. So there are different things going on there. So they can be squiggling around, running away. So the blue guys leave, and the yellow guys jump on. So we are actually changing the matter. In general, we're trying to look at which change is it. Physical and chemical changes can be hard to identify, so we will be looking at this in class through some handouts. We have to look at the fact it does this. What is it changing? We need to know a little bit about what it was before. And we need to know something about the materials that we're playing with. So if we're playing with food dyes and it changes color, then we'd expect that because they're dyes. But if we're playing with 2 clear colorless items and they change color, we're totally not expecting that. So that would be a chemical change. So physical or chemical changes can be tough to identify, or we have ambiguous results, so we have to know about them. Chemical changes often result in a release of energy. Sometimes they take in energy, and sometimes they get rid of energy, or we see light. Physical changes can often be easily reversed. So we can melt, we can freeze, and then we can boil, and then we can condense. So we can change those states. And once again, we also have some irreversible ones, like ripping the piece of paper. We just can't set the paper beside itself and it just adhere itself back together. But Play-Doh, you can do that, so that would be a physical change. So there are some that are a little ambiguous or confusing, but we'll look at a lot of examples in class. change of phase is physical, and we can confuse that just based on observations. So in the lab and class examples, we should be able to clear a lot of those up. So that concludes our first video for matter. So we went through the different states or phases of matter, as well as physical and chemical changes, and we will be working on those in class. Have a good night.